Okay, so today we're going to be applying systems of equations using word problems. So I had you write down these 4 steps, and we're going to be using this with every single problem that we do today. So I gave you a worksheet that has 10 different problems on it. So if we get through 5 of them, then you have half your homework done. Okay? I'm going to be doing number 1. Number 2 looks just like number 1. I'm going to be doing number 3. Number 4 looks just like number 3. Does everybody understand? Okay, so let's start with this one. Demi is older than Ashton. The difference of their ages is 12, and the sum of their ages is 50. Find the age of each. Okay, exactly. The first thing we need to do is we need to define a variable. So, Daniel, why did you say A plus C? Awesome. So, Ashton, let's let Ashton be A, and Demi be D. Okay, our second step is to set up equations. Okay, so let's relate this to real life. How would I write the difference of their ages is 12? Why did you say D minus A? Because she's older, right? So if we're trying to find the difference between their ages, I'm going to say Demi minus Ashton's age is going to equal 12. No, the difference in their ages, right? And the sum of their ages is 50. So I would say D plus A equals 50. All right, so now I have a system of equations. It's what we've been doing for a couple weeks now, right? Hold on. Everybody write it down really quick. Hold on. Okay, so in order to solve this system, we need to eliminate. So we're going to eliminate Ashton. Why can I eliminate Ashton? Cassandra, how come I can eliminate Ashton? Good. They have opposite coefficients, so that goes away. So I'm left with 2 Demis equals 62. So if 2 Demis equals 62, how much is 1 Demi? 31. How did you figure that out? Divide 62 by 2. All right, so now I know how old Demi is. Demi, I should say. So how do I figure out how old Ashton is? If I know Demi is 31, and I know the difference between their ages is 12, and the sum of their ages is 50, then which one do you want to plug it back into? The second one? Okay. So we have D plus A equals 50, so we have 31 plus Ashton's age equals 50. So how would I solve that? Christina, how would I solve this? Subtract 31. Good. Subtract 31, and I would get Ashton equals how much? 19. So the last thing we need to do is look at if our answer is reasonable or not. So without doing math, or at least without doing the procedural math, just mental math, how could you figure out whether or not your answer is reasonable? Okay, but we want to plug it in mentally, Alex. So I want to look back and say, okay, the difference of their ages is 12. Is the difference between 31 and 19 12? Yes. What about, this one's easier, is the sum of 31 and 19 50? Yes. So we've just done a mental check. Because sometimes when you go back and you do a check using a procedural method, sometimes you repeat the same mistakes that you made. right? So sometimes it's the best thing to do is to go back and mentally see if it makes sense, right? Okay, so let's move on. Here's the next one, and it's also on your worksheet, but it's number 3. So Cammie has $1.65 in nickels and dimes on the table. There are 12 more nickels than dimes. How many of each kind of coin does Cammie have? Okay, so again, our first step is to define our variables. So I'm going to go ahead and say nickels are going to be N, and dimes are going to be D. So everybody think of having a bunch of change on the table. So how could I set up one of those equations? What do I have on the table? $1.65, okay. I have nickels, and I have dimes, and they total to, but I'm going to write 165 cents. Because 165 cents is easier to deal with than $1.65, right? Yeah, no decimals. We got rid of the decimals. Okay, but when I count change, do I count 1 nickel, 2 nickels, 3 nickels, 4 nickels, 1 dime, 2 dimes? How do I count it? I count by the number, right? Easier. I wouldn't say, oh, I have 15 nickels, now I'm going to multiply it by 5, right? You don't do that when you're counting change. So you count your nickels by 5, and you count your dimes by 10. And all we're really saying when I write it like that is nickels are worth 5 cents, but I don't know how many I need. Dimes are worth 10 cents. I don't know how many of those I need, but when I add those two together, I'm going to have $1.65. Everybody with me so far? Okay, here's the confusing part. I'm going to go ahead and make these infinitely. So the next part says there are 12 more nickels than dimes. So imagine you have a dime on the table. Do you have 1 nickel on the table? You do. Not only that, for every dime, you have 1 nickel and what else? How many more nickels do I have than dimes? 12. So how many nickels would I have in all? We would have 13. Hard to imagine that, though, isn't it? Because the way I'm saying it, you'd think, oh, there's 12 dimes. I'm sorry, there's 12 nickels and there's 1 dime. But there's not. If there's 1 dime on the table and there's 1 nickel, then I need, because if they were even, it would be 1 and 1, right? But if there's 12 more, more means above 1. So there'd be 13 nickels. Okay, so the way that we write that, let me put these back. The way that we write that using an equation is if I have, how many nickels do I have on the table? Okay, so I have the nickel, I have 12 plus a dime. Didn't say that quite correctly. The way that I know how many nickels I have is I know I have so many dimes and then I add 12 to that. Does that make more sense? Yeah. So if I had 5 dimes, how many nickels would I have? 5 dimes means I have 5 dimes, so I have 5 nickels, correct? Let's start with just 2. If I have 2 dimes out on the table, then I would also have 2 nickels, right? Plus how many? They both are even right now.
Yeah.
So how many more nickels would I have to put on here? Not 2 more. 12 more. Because doesn't the statement say there's 12 more nickels than dimes?
Yeah.
So if I have 2 nickels and 2 dimes, I would need 12 more nickels because there's always going to be 12 more nickels than there are dimes. So that's what this statement says right here. It's saying, however many dimes I have, add 12 to that, and that's how many nickels I've got. Make sense? Okay. Does it make sense why we don't do it the other way around?
Yeah.
Because it looks funny, like, why do we have the D plus 12 when there's more nickels than there are dimes? Okay, so now I have two separate equations. So now I have a system of equations. So how could I solve for it? Good. So we're going to substitute. So anywhere I see a nickel, I'm going to substitute it for this value right here. Okay, so I'm going to rewrite the equation. 5n plus 10 dimes equals 165. And I'm going to substitute in here 12 plus D. What's my next step, Blossom? What do I do from here? Distribute. Good job. I want to distribute that 5. And I get 60 plus 5 dimes plus 10 dimes equals 165. How many dimes do I have in all? 15 dimes plus 60 cents equals 165 cents. Finally, 15 dimes equals how much? 105. How did you figure that out, Cassandra? Take 60 cents off of each side and you get 15 dimes equals 105. If 15 dimes equals 105, how many does 1 dime equal? Or how many dimes are there, I should say? What times 15 equals 105? 10 times...
No. Sure.
Almost. Think of, okay, so 8 times 5 is 40. Does that end in a 0? Does 6, and 6 times 5 is 30. Does that end in a 0? 9 times 15. Think, what's 10 times 15? 150. Are we close to 150? 7 would be more reasonable. I'm trying to get you guys to be able to think of this stuff in your head. Exercise that brain. If I were to do that using a procedural method, what would I do?
105.
105 divided by 15. Right? We could have done that as well.
Okay.
So there's 7 dimes. Who can tell me how many nickels there are then? How much? How do you know that? Right? There's 12 more nickels than there are dimes, so there must be 19. But if we were to also do that using substitution, which one would you want to use? The first one? That one looks more complicated. The bottom one, right? Could I use the first one though?
Yes.
Yes. So nickel equals 12 plus however many dimes, and how many dimes do we have? 7. So there are 19 nickels. All right, more mental math. How much is 20 nickels? How do you know? I'm sorry? One more time, how do you know? Because 20 times 5 is 100, right?
Yes.
Or if you didn't know that right off the top of your head, you could say 10 times 5, well, that's 50 cents. So 20 times 5 would be a whole dollar. How much is 7 dimes? 70 cents. Add that up in your head. How much is $1.70? $1.70. But did we have 20 nickels? How many nickels do we have? 19. So how many do I need to take away? 1 nickel. Take 1 nickel away from $1.70. Is that what we needed?
Yeah.
Is my answer reasonable?
No. Yeah,
It is. It is reasonable. Okay, so this one is a little bit more like what you've seen before.
Yeah.
So it says the sum of two numbers. Let me change my color. The sum of two. What does sum mean? Addition, right? So the sum of two numbers. So what was my first step that we did on the last two problems?
Define variable.
Define the variables. What do you want to use? A and B? We can use A and B. So let one be A, the other B. So how do I write the sum of those two numbers? Leanne, how do I write the sum of those two numbers? Okay, so if we're calling them A and B, how would I write the sum of A and B? What does sum mean? Plus, how would I write? I can't even say it because I'm just going to give you the answer. A plus B, good. So I have A plus B. What is the sum of two numbers? It tells you, 70. The sum of two numbers is, what does is mean in an equation?
Equal.
Equal. The sum of two numbers is 70. One number is, there's a clue. What do you think I'm going to have for this right here? Is equals. One number, well, what's one of the numbers? Huh? I'm sorry? No. A or B? Which one do you want me to use? A. So A is what? 10 more. How do I write 10 more?
10
Plus 10.
Oh.
It means 10 more, right? Add 10 to it?
Mm-hmm.
So 10 more than twice the other number. How do I write twice the other number? 2B. Make sense? How do I solve for that? We could substitute, right?
Mm-hmm.
But let's use elimination. How do we use elimination?
Getting them both the same way.
Getting them both the same way. Do they both have A's and B's on one side?
No.
So what could I move?
The B.
We could basically move whatever we want, right? But doesn't it make the most sense to move B over here? Okay, so let's do that. I'm going to rewrite this as A plus B equals 70, and A minus 2B, right? If we put it on the opposite side, it's going to have the opposite sign. So A minus 2B equals 10. Can we eliminate yet?
No.
No, we don't have anything that has opposite coefficients, right? How do we do that?
Multiply the top by 2.
You want to multiply the top by 2? What else could I do? I wouldn't want to divide the bottom,
No.
because then I'm just going to have fractions. You could, Anthony. I could multiply the bottom by a -1, take the opposite of everything on the bottom. Which one do you guys want to do? We could multiply by 2, or we could make everything on the bottom the opposite sign. Okay. Totally up to you. So A is going to become negative. Negative 2B is going to be positive, and 10 is going to be negative. Excellent. So the A's are eliminated, and I'm left with 2B's plus 1B is 3B's equals 60. If 3B's are 60, how much is 1B? 20. 20, 40, 60, right? Or just divide.
Yeah.
So B equals 20. How do I know what A is? I don't even need to. Right, Alex, how much is B? I'm sorry, A? Look over here. Look at this. A and B are 70. I know B is 20. How much is A? something plus 20 equals 70. What would A be? Let's look at it over here.
50?
Yeah, 50. I wanted you to think about it. Do you see that?
Yeah.
But we actually need to
Substitute it.
do it procedurally, yes, and say A plus 20 equals 70. So A equals 50 if I subtracted 20 from both sides. Correct? Okay, what's my last step? Not plug it back in. Does it make sense?
Yes. Yes.
The sum of two numbers is 70. 50 and 20, does that make 70?
Yes.
Yes.
One number is 10 more than twice the other.
Yes.
10 more than 20 is 30, and twice that would be 60. That doesn't make sense. Did we do that right? One number is 10 more than twice the other. Oh, we need to double 20. What's the double of 20? 40 plus 10? Okay, that makes sense. Two angles are supplementary. Their sum is 180. So what are we going to make those angles? First of all, this is a supplementary angle. What are we going to call the first angle? T? Sure. What do you want to make the other one then? U? All right, T and U. Angles T and U. What about angles T and U? Their sum is 180. Good. T plus U equals 180. The measure of one of them is 30 more than 2 times the other. How would I write that? T equals 2 U's plus 30. That's messy. How do you guys want to do this one?
Can you try that equation on this?
Sure, you want me to? Thank you for reminding me. A strong one. It's just in a different font. Let me change the font really quick. Okay, so I have T equals 2 U's plus 30. It made it an N. Well, I have to practice with it, right? Okay. So T plus U equals 180, and I know 1T equals 2 U's plus 30. So how do you guys want to solve this one? Did you like doing that last time, or would you rather substitute? You like eliminating rather than substituting? Okay. Everybody okay with that? All right, so let's rewrite it. I have T plus U equals 180, and T minus 2U equals 30. Same as last time, put the opposite sign?
Yes.
So I have opposite of T, opposite of 2U, opposite of 30. So when I total those together, I eliminate T. I have 3 U's equals 150, so 1 U equals 50. If U is 50, what is T? Not 30.
130.
130. Good. So I want to substitute this back in here. So T plus 50 equals 180. Therefore, T must be 130. Does it make sense? If T is 130, and U, it's much easier when you have a picture, and U is 50, does 50 and 130 make 180 degrees?
Yes.
Yes.
Oh.
Okay, we'll do the best we can. So the perimeter of a rectangle is 350. What does perimeter mean?
The area around it.
Not area around. That gets confusing. More specifically, it's all the way around it. The distance around it. So if the perimeter is 350, and I know I usually have width, width, length, length, right? To go all the way around something?
Okay.
This says that the width is 15 centimeters shorter than the length. How would I write that? Width means equals. How would I write 15 centimeters shorter? Minus 15 from what?
Well, from 350.
From the length.
Yes.
All right, guys. See you tomorrow.
Sure.
So instead of length up here, I'm going to put, instead of width, I'm going to put length minus 15. I'll post this for you guys, okay? So now to go all the way around my figure, I would have 4 length minus 30 equals, thank you, 350. Add 30, 4 length equals 380, so 1 length equals, let's see, 4 goes into 38 how many times? Nine times 4 is 36, with 20 left over would be 95. So if the length is 95, then the width would be 15 less than that, which is right here. So the width equals 95 minus 15, which is 80.